Hi everyone, this is Dr. Nak, and today we're going to talk about composition of functions. So before we begin, let's just talk about what is a composition of functions are. So we have two functions going on when we talk about the composition of functions. We have function g, and then we have a function f. So here's the picture. I already drew it for you. So x is our inputting value. Now we're going to put our x into a function g. Now the output is denoted by g of x. Now we usually stop right here, right? But for the composition, guess what? You're gonna have to input our g of x into f. Okay, so now our inputting value is g of x. We're gonna put that inside of a function f. Now the output is denoted by f of g of x. Now the notation for that is we write it as f of g of x. All right, so there's the of means that there's a little circle there. That's the notation for the composition. Now, please note that this does not equal to f times g of x. Okay, so let's do an example by using this picture. Okay, so suppose our g of x is defined by square root of x, and then f of x is x cubed plus 1. All right, now I'm going to change the color a little bit. Here's our inputting value. Now we're going to plug that inputting value into a machine g. You can think of, g of x being a machine. Now the output is going to be square root of whatever that you're going to input. So this is same thing as, so let me just write it. G of x is going to be the square root of x. So now this is going to become the output. All right, now what we're going to do is we're going to input our square root of x into a function f. Okay, so if I do that, then what you're going to have to do is you're going to have to replace this x with whole entire square root of x. So the outcome or the output, let me just write it as output. So this is going to be the square root of x to the third power plus 1. Don't worry, we're going to do a bunch of examples, especially for this section. Okay, so let's first go with the definitions. I already wrote it out, as you can see. So we have the composition of functions. The composition of two functions, f and g, is written f circle g, we call it as f of g, and is defined by f of g of x equals f, and then g of x become the argument of our f. So we call this f of g of x. All right, so let's take a look at example 1. Let f of x be 4x minus 3, g of x is 2x plus 7. Find f of g of x. All right, so let's take one thing at a time. So I'm going to write every step out. So we got f of g of x. Now this is the notation for that is f of g of x. All right, so step 1, write your g of x. So what I mean is this. I'm going to go f of, well, what's my g of x? Our g of x is 2x plus 7. Okay, so before we compute this, right? Sorry, let's take a look at this. All right, so how would you compute f of 2? So this is telling you, look at function f, right? Which is here, replaces x with 2. So what I need to do is I need to replace x with a 2. Wherever the x appears, I need to replace that with a 2. So here I can rewrite this as 4 times 2 and then minus the 3. So then this is going to become, what is that? 8 minus 3, so it's going to become 5. All right, so now let's look at f of a. So this is the same thing, right? This is telling you look at function f, replaces x with what's in the parentheses, which is a. So what we need to do is just, if the x becomes a, then this also becomes a. So here, our answer is going to be 4a and then minus 3, right? So now let's look at this. F of happy face. All right, so what do we do? I know this is so not math right now. So what we need to do is what? Same argument, right? You need to replace x with what's in the parentheses, which is a happy face. So we have f of happy face equals 4 times the happy face. What kind of math am I teaching you right now? And then minus the 3. All right, now we're going to do the same thing. So now let's go back to our problem here. Okay, we're going to do the same exact thing that what we just did. So pretend this whole 2x plus 7 is your happy face. Okay, so what do? This is telling you that look at function f, replace his x with what's in the parentheses, right? So in this case, we're going to have to replace our x with 2x plus 7. All right, so let me just write it out. So this is going to be the same thing as 4 times 2x plus 7 and then minus 3. Did you get that okay? So what I mean is pretend this is your happy face, right? This whole thing. So what I did was I did the same thing as what we did earlier. So this whole thing, it's going to become happy face. So you're going to have a 4 times the happy face minus the 3. All right. So then let's just keep going. So then how do we simplify? First, let's just distribute the 4. So you're going to have 8x and then plus 28 and then minus 3. So it looks like we're going to have 8x and then plus 25. And so that's going to be our answer. Let's take a look at example 3. Let f of x to be 2x to the third, g of x equals 3x squared plus 2. Question is, find f of g evaluated at 1, g of f of 1, and g of g of 1. Now, there are 2 ways that you can compute this. So let me show you both ways, and you can pick and choose whichever method that you like to do. Okay, so let me just call this method 1. Okay, method 1 is actually to compute f of g of x, then plug that 1 into that resulting function. So first, let me just go with f of g of x first. Then after we compute that function, then we're going to replace x with 1. So first, let me just rewrite this as f of g of x. So we're going to do the same thing as before. So this is f of 3x squared plus 2. Now you better be looking at f of x now, and your job is to replace its x with what's in the parentheses. So here you're going to have 2 times 3x squared plus 2 to the third power. Now, since I didn't ask you to simplify it, leave your function the way it is. Now, with this, so this is our f of g of x. So if I want to compute f of g of 1, what do you think we need to do? Well, we're going to have to replace the x with 1. So here what we're going to get is 2 of 3 times 1 squared plus 2 to the third power. So this is going to be 2 times 1 squared is 1. So you're going to have 3 plus 2 to the third. So this is 2 times 5 to the third, which is 2 times 5 to the third is 125. I'm running out of room. So 2 times 125 is 250. So here's one way to do it. But do you see that if you computed f of g of x, that function, to be a little bit off, meaning suppose you made a mistake on computing f of g of x, then do you see that f of g of 1 value is going to be off too? So here's the safer way to do it if you're not quite sure if your f of g of x is correct. So let me call this method 2. I'm going to call this the safe way. Okay, so first what we're going to do is this. Let me just write it out. F of g of x, g of 1, sorry. Okay, so let me write down the definition. So this is f of g of 1. Okay, so next step is this. Compute g of 1 first. Our g of x is 3x squared plus 2. So let me just work it as a side work. So I'm going to take this g of 1 and let's compute on the side. Our g of x is, again, I'll write it out, is 3x squared plus 2. That's a squared, sorry. So our g of 1 is going to be 3 times 1 squared plus 2, which is 5. So now, next step, this is going to equal to f of, well, we just computed g of 1 is 5. So I'm going to replace the g of 1 as 5. Now this is telling you, look at function f of x, replace its x with 5. So from here, since our, since our f of x is 2x to the third, our f of 5 is going to be 2 times 5 to the third. Does that make sense? So this is going to be 2 times 125, which is 250. But let me just go with it. So this is going to equal to f of 5, so which is what I just wrote, 2 times 5 to the third. Now, which gives us 2 times 125, and our answer is 250. So, hopefully, we better get the same answer by doing method 1 and method 2. I'm not sure which method that you like, but pick your favorite weapon. Okay, now let's go with g of f of 1. I'm not quite sure which method that you like, but a lot of students like method 2, which is the safe way. So let me just compute it in that way. So here, let's go with g of f of 1. So again, we're going to do this the safe way. So here, let me rewrite g of f of 1. All right, now as a side work, first compute your f of 1. Okay, our f of x is 2x to the third. So that means f of 1 is 2 times 1 to the third, which is just 2. So I'm going to replace our f of 1 now with 2. Okay, so now this is telling you, look at function g of x replaces x with 2. So in this case, since our g of x is 3x squared plus 2, maybe I'll write everything out for you. G of x is 3x squared plus 2. That implies that g of 2 is 3 times 2 squared plus 2, which is, what is that? 3 times 4 plus 2. 3 times 4 is 12 plus 2 is 14. So that's how it's going to have to work. So let me just write. Now g of 2 is, again, 3 times 2 squared plus 2. So which is 3 times 4 plus 2, which is going to give us 12 plus 2, which is 14. Okay, now let's try g of 1. So again, I'm going to try to do this the safe way. G of 1. Let me rewrite. So this is g of 1. I know that we already computed the g of 1 earlier, but let me just do it again, just in case you missed it. So let's go with g of 1, but our g of x is 3x squared plus 2. So g of 1 is 3 times 1 squared plus 2, which is 5. Okay, so now I'm going to replace our g of 1 with 5. Now this is telling us now that compute g of 5. So in place of x, we're going to replace that x with 5. So now what we're going to get here is 3 times 5 squared plus 2, which is 3 times 25 plus 2, which is, 75 plus 2. So our answer looks like it's going to be 77. Okay, so now let's go with another notation. So f plus g of x, this is just a shorthand notation for f of x plus g of x. Same thing here, f minus g of x is same thing as f of x minus g of x. fg of x, so this is same thing as f times g of x, which is same thing as f of x times the g of x. Now f over g of x is same thing as f of x over the g of x. Now we have something new, right? F of g of x. So the shorthand notation for that is f of g of x. So now our next game is this. We want to find the domain of a composition of functions. Now, I think best way to do this is by practicing. But anyways, let's just read through what your textbook says. It says a domain of a composite functions f of g of x is the set of those inputs x in the domain of g for which g of x is in the domain of f. You're like, say what? Yeah, don't worry. I said exactly the same thing. But anyways, let's go over how to find the domain of f of g of x. All right, so step number 1, what they want you to do is find the domain of g. And step 2, find the domain of f. And then step 3, the wording gets a little bit confusing. Here again, it says exclude inputs x from the domain of g for which g of x is not in the domain of f. Okay, do not panic. We got this. Okay? Okay, so here's my own version of what the textbook is asking you to do. So actually, your textbook only does it in method 1. Now, there's another way to do it, which is method 2. But in order to use method 2, you better be a master of computing the composition of functions. But anyways, let's just go over what the textbook is telling you to do. So that I'm going to call that method 1. Okay, so step 1, same thing, find the domain of g. And then box the answer. All right, now step 2, find the domain of f. All right, and then step 3, set g of x does not equal to x values found in step 2. All right, so the game is set g of x, whatever the function that you're given, does not equal to whatever the x value that you're going to get from circle 2. All right, now step 4, solve for x, and then there is your answer. Box the answer. Now the total answers are going to be the answer that you got, whatever that you boxed from step 1 and from step 4. And let's just go over method 2. So step 1 will be this, find the domain of g, same step, all right, as the method 1. Now box that answer because that's going to be your one of the part of your answer, final answer I should say. Step 2, compute f of g of x. Simplify all the way until you get one fraction. All right, now step 3, just directly find the domain of that fractional expression that you get from step 2. Okay, so keep that in mind and let's do some examples. All right, example 3, let f of x equals 5 over x minus 1 and g of x equals 4 over 3x minus 2. Find f of g of x and the domain of f of g of x. All right, so let's do one thing at a time. So let's first find f of g of x. Don't worry, I'm gonna work everything step by step. All right, ready? So write down next step, write down the shorthand notation for f of g of x. So that will be f parentheses g of x and then parentheses closed. Okay, now next step, replace your g of x. So this is going to become f of our g of x is 4 over 3x minus 2. So far so good? Okay, so now what you need to do is you need to replace what's in the parentheses in place of x, right? So if I do that, then this is same thing as 5 over 4 over 3x minus 2 and then minus 1. Now, please do not leave your answer like that. Please simplify all the way until you get one fraction. Okay, now how to do that is this. It's not as bad as you think, so multiply everything through by the LCD. Okay, so LCD, least common denominator of all three terms that you see. So the denominator of 5 is same thing as 5 over 1. So the 1 is the denominator. Same thing as minus 1, the denominator is 1, but the denominator of 4 over 3x minus 2 is just 3x minus 2, right? So the LCD of it is going to be 3x minus 2. So just multiply everything on the top and the bottom by 3x minus 2, whole thing by 3x minus 2. All right, now what we're going to do is we're going to distribute 5 to each term, which is 3x minus 2. And then I'm going to distribute this whole quantity 3x minus 2 to each term in the denominator. Okay, so if I do that, then this is going to become 15x and then minus 10. All right, and that's the numerator because all I did was I distributed the 5 into 3x minus 2. Now, all over. So let's do this step by step. So now what I'm going to do is I'm going to multiply 3x minus 2 to 4 over 3x minus 2. So what's going to happen? You get to cancel out the 3x minus 2, correct? So here, I'll just write every step out then. Okay, so if I distribute that, then here you're going to have 4 times 3x minus 2, and then all over 3x minus 2, and then minus 1 times 3x minus 2. All right, you don't have to write this step out. All I'm just trying to do is show you, how to do this step by step by step. So now what can I do? I can cancel the 2x minus 2's, and then let me just go over here. So then you're gonna have just 4 minus, and then you're going to have to distribute minus 1 to each term, which is 3x minus 2. So you're going to have minus 3x and then plus 2 because you're distributing the negative 1. Okay, so now let's not forget our poor numerator there. We usually forget, we get so focused on simplifying the denominator, but numerator is still 15x minus 10. All right, so let's go one more step. So it looks like we're going to have 15x minus 10 all over, and I could combine 4 and a 2 to get 6 minus 3x. All right, so that's gonna be our answer for f of g of x. All right, now let's go with the domain of f of g of x. So what I'll do is this. I'm gonna show you how to do method 1 and method 2. Okay, so let's first go with method 1, which is the textbook's way. Let me just go method 1. And let me just copy and paste what we wrote earlier. So this is the method 1. Okay, so what we're going to do is let's first follow what the textbook is asking you to do. So step number 1, to find the domain of f of g of x, step 1, find the domain of g. Okay, so I'm just going to write it as step 1. Let's find the domain of g, where our g of x is 4 over 3x minus 2. Okay, so this is a rational function here. So think of it as a fraction, right? So what can we not have on the denominator? 0, right? So what this is, so to find the domain of g, 3x minus 2 cannot be 0. Now solving for x, we're going to have 3x cannot be 2, so x cannot be 2/3. All right, box that because this is going to be a part of your final answer. All right, now let's go with step 2. Find the domain of f. Okay, now where our f of x is, what was our f of x? 5 over x minus 1. Now remember, we're finding the domain of f, so the denominator cannot be 0, right? So we're going to write it as x minus 1 cannot equal to 0. So that implies that x cannot be 1. I'm not going to box that. All right, now step 3 is this. It says set g of x, which is 4 over 3x minus 2, does not equal to the x values found in 2, which will be 1. So next step, what you need to do is you just bust out your g of x, which is 4 over 3x minus 2. And then you're going to have to write that does not equal to this x value found in step 2, which will be 1. Okay, now step 4 is this. All you have to do is solve for x from step 3. All right, so there are a couple ways that you can do. The easiest way for me to do is just multiply everything through by the LCD. So which is going to be just 3x minus 2, and then multiply this by 3x minus 2. All right, so then what do we get? Let me just, I'm running out of room. So if I do that, then do you see that I'm going to have 3x minus 2 times 4 over the 3x minus 2? That's not equal to 1 times 3x minus 2, which is just 3x minus 2. Now the good thing is that I can kill the 3x minus 2's. And so let me go over here. So then what do we get? 4 does not equal to 3x minus 2. All right, now add 2 on both sides. Then you're going to have 6 does not equal to 3x. Now dividing by 3, it looks like we're going to have x cannot be 2. So our answer is going to be settable x values such that x cannot be 2 and x cannot be 2/3. But let's try to understand what we just computed. So the first x value, right, x cannot be 2/3, that's the domain on G. So if I look at G and then if I replace x with 2/3, do you see that the bottom is going to go to 0? And we cannot have 0 on the bottom, correct? Because we're looking at this as a fraction. Now the question is, why do I need to include that value in for the domain of f of g of x, right? So look at it this way. So if I have, let me see, where can I write it? I'm just going to write it like this. In order to compute f of g of x, this was notation, isn't it? So f of g of x. So think of it in this way. We just computed the domain of our g, which means that if I plug 2/3 into our function g, our g of x becomes undefined. Now, so how can I plug it in the undefined value into f? It doesn't make sense, right? Because if I plugged it in something that's undefined into f, everything's going to become undefined. So for that reason, you're going to have to keep 2/3 as the domain of f of g of x. And for the second one we got, which is x cannot be 2, it cannot be because look, if I plug it in 2, so remember this expression here was f of g of x, right? So if I plug it in 2 in place of x, what's going to happen? You're going to have 6 minus 3 times 2, 6 minus 6, which makes this whole denominator goes to 0. Again, we cannot have a 0 in a fraction, right? So therefore, we need to keep both of them. Okay, so now let's finally write down our answer in set notation and interval notation. Now, I am completely run out of room here, so I'm just going to write our answer at the top, if you don't mind. So I'm just going to write it as therefore the domain of f of g is settable x values such that x cannot be 2/3 and x cannot be 2. All right. Now, in order for us to do the interval notation, you can just draw a number line if you want. So here's negative infinity, infinity. So 2/3 is smaller than 2, right? So I'm just going to write it 2/3 here and then 2 here. So x cannot be those two values. I'm going to have an open circle and I'm going to shade everywhere else. Just translate where you shaded, right? So you're going to have negative infinity to 2/3, open, union, and then 2/3 to 2, open, and then union to 2, infinity. So those two are going to be our final answer. Okay, so that was just by method 1. Now let's take a look at method 2. Okay, so let's try method 2. So let's just recall that step 1 will be finding the domain of g, which is same thing as method 1. And step 2, compute f of g of x and simplify all the way until you get the expression into a 1 fraction. And number 3, or step 3, find the domain of circle 2. All right, so let's recall our f of x and g of x. Okay, so here are our f and g. And first step is this. So you know what? We already computed f of g of x, but let's just do it again just for heck of it. So step 1, find the domain of g. All right, so the domain of G is that 3x minus 2 cannot be 0. So that implies that, let me see, 3x cannot be 2. So here our x cannot be 2/3. And we're gonna box this answer because this is gonna be a part of our answer. Now step 2, what we need to do is now compute f of g of x. I know we did that earlier, but let's just, for fun, let's just try it again. So we got f of g of x. Remember what to do. Replace your g of x first, which is 4 over 3x minus 2. What is that? Okay, and then you plug this whole quantity into wherever you see your x in f of x. So in this case, you're going to have 5 over 4 over 3x minus 2, and then minus 1. And then remember the trick, multiply everything by the LCD, which is 3x minus 2. And then you just, on the top, you distribute the 5, and then on the bottom, you distribute 3x minus 2 to each term. So then here, what do we get? I'm just going to distribute the 5 in. 15x minus 10 all over 4 minus, and then here you're going to have 3x minus 2. Do not forget that parentheses. So you get 15x minus 10 all over 4 minus 3x and then plus 2. So 15x minus 10 all over 6 minus 3x. Just like what we got earlier. Okay. So now let's go with, so now look at it. It's in one fraction. So we basically simplified it all the way. So our step 3 is to find the domain of circle 2. So basically find the domain of this guy right here. Okay, so what's the restriction? Well, the bottom cannot be 0. So that implies that we have 6 minus 3x cannot be 0. So that implies that 3x cannot be 6. So that implies that x cannot be 2. Isn't that exactly the same answer that we got by using method 1? It better be the same. Okay, so again, our method 2, our answer is going to be, so I'm going to write it as therefore, the domain of f of g is settable x values such that x cannot be 2/3 and x cannot be 2. Exactly the same answer. Okay, now let's just do this again. To get the interval notation, circle, open circles around 2/3 and 2, shade everywhere else. So negative infinity to 2/3, open, union 2/3 to 2, union, and then 2 to positive infinity as we expected. So which method did you like better, method 1 or method 2? Just stick with the way that you feel more comfortable with. I usually like to use method 2, but if you're not comfortable computing f of g of x like what we did here, then I will stick with method 1. Okay, but if you are a master of computing f of g of x, then I will go with method 2. But choose your favorite weapon. Okay, so let's do another example. Example 4. Let f of x be x plus 2, g of x be square root of 3 minus x. Find f of g of x and the domain of f of g of x. All right, so first, again, let's first go with f of g of x. All right, so this is same thing as f of g of x. So next step, replace your g of x. G of x is the square root of 3 minus x. All right, now what we need to do is look at function f and then replace his x with what's in the parentheses. Okay, so then what do we get? We're going to have a square root of 3 minus x and then plus 2. So this is going to be our answer for f of g of x. So this will be the expression for that. All right, now let's go with the domain of f of g of x. All right, so for this particular problem, I'm just going to go with method 2 because to me, that's a lot more simpler and less thinking. But anyways, so if I applied method 2 to this, okay, so the step 1 was what? Find the domain of G. Okay, so the domain of G, be careful, we got a square root is going on, right? So what's the rule for the square root? So remember, whoever sits inside of the square root has to be greater or equal to 0. Remember? Because square root of a negative number is undefined. All right, so the restriction is going to be 3 minus x better be always positive, which is same thing as saying greater or equal to 0. So now I'm going to add x on both sides. Then you're going to have 3 is greater or equal to x. Well, this is same thing as x is less than or equal to 3. All right, so I'm going to box that. And then step 2 was, remember, compute f of g of x, but we just did that. Okay, so our answer for that is, let me just write it as f of g of x is square root of 3 minus x and then plus 2. And then the third step was to find the domain of circle 2. Find the domain of this. All right, so don't complicate your life. So what's the only restriction? Only restriction appears what's in the square root. So here again, only restriction that you're going to have is that the argument of the square root must be greater or equal to 0 all the time. So which boils down to the same situation here. So we're going to get the same answer. So in this case, 3 minus x has to be greater or equal to 0. So that means that x must be less than or equal to 3. So I would box that if I had to follow step by step method. So guess what? There's only one answer. Okay, so therefore, the domain of f of g is settable x such that x is less than or equal to 3. And then let's do the interval, but I'm just going to draw it out graphically. So x is less than or equal to 3. So, or you could have a closed bracket, closed dot here means the same thing. So all the x's are less than or equal to 3. So here it is. So how do I translate that in interval notation? Is open negative infinity to 3, closed. And that's all you have to do. Okay, so now let's play a different game. So let's just look at example 5. It says write f of x equals square root of 3 minus x squared as the composition of two functions. So here, what we want is we want to come up with two functions f and g such that if I compose f and g, our result is going to be square root of 3 minus x squared. Okay, so I'm just going to write it out. What we want is f of x and g of x such that f of g of x is going to give us square root of 3 minus x squared. So in order to do this, right, we're going to have to look at the big picture. So what do we got going on? So first of all, the big picture is that we have a square root of something, right? And what's a little bit more tedious is 3 minus x squared. So our f is going to be the big picture that you see here, which is going to be square root of x. So let me just go with that, and then we'll prove to make sure that f of g of x is going to give us what we're looking for. So I'm just going to say let f of x to be the big picture, which is just the square root of x. All right, and then I'm going to say let g of x to be just a little more tedious ones, so which is 3 minus the x squared. All right, so this is what I'm going to choose. Okay, so now let's check. Our f of g of x, I'm just going to write it in shorthand notation already. So this is f of g of x, which is 3 minus x squared. So now what we need to do is you're gonna look at function f, right, and replaces x with what's in the parentheses, right? So then what do we get? This is same thing as the square root of 3 minus x squared, which is exactly what we're looking for. Okay, so what I'm going to do is I'm going to box our f of x to be square root of x, and then g of x to be 3 minus x squared. By the way, there are many ways to come up with your f of x and g of x. Okay, so depending on how you view it, so you can start out like this as well if you wanted to. So I could also let f of x to be like maybe square root of 3 minus x, right? And then our g of x to be just x squared, right? So if I did that, then what do we get? F of g of x is f of x squared, right? So then what do we do? Look at function function f and replaces x as what's in the parentheses, right? So here you're also going to get square root of 3 minus x squared. So what I'm trying to say is that the f of x and g of x are not unique. So just because your answer looks different than your teammates' answers, that does not mean that you did something wrong. So this is also an acceptable answer. I just wanted to let you know that. All right, so now let's look at example 6. We're going to do the same thing. So what I want you to do is this. Please pause the video and try this problem. So what I want you to do is write h of x equals 5 over 3 minus square root of 4 plus x squared as a composition of two functions. So again, please stop the video and try it. All right, so let's take a look. Okay, so again, your answer might be different than mine. It all depends on how you view it. Okay, so this is how I see it. So first, I'm just gonna let f of x to be, maybe I could just go, what's the big picture? Well, maybe 5 over 3 minus the square root of x, right? And then I'm gonna let g of x to be 4 plus x squared. All right, so I think this will work out. So let's just check f of g of x. So this is f of 4 plus x squared. So now let's see, you need to look at function f, and it replaces x with what's in the parentheses, right? So then this is going to become 5 over 3 minus the square root of 4 plus x squared, which is exactly what we wanted up here. Okay, so it checks. So I'm going to box this for the answer. But again, you could come up with all sorts of different f of x and g of x. So if you want me to check to make sure that your f and g are correct, please email me, okay? So what did y'all think about this section? Was it bad? Was it not too bad? I really had a difficult time doing composition of two functions when I was a student. So again, feel free to let me know if you have any questions at all. Okay, so but for now, great job everyone, and I will see you next time.